We're on to 11.3c. We're going to find polynomials with specific roots, and we have 7 previous videos linked in the description. If we're given several numbers, we can find a polynomial having them as its roots. I want you to remember this theorem, the factor theorem from video 11.2c. For a polynomial p of x, if p of r equals 0, then the polynomial x minus r is a factor of p of x. So we talked about that one. If you haven't seen it, you can click the description. We can find a polynomial of degree 3 having roots -2, 1, and 3i, and by that factor theorem, that one from video 11.2c. Such a polynomial has factors x plus 2, x minus 1, and x minus 3i. Well, this means that the polynomial p of x equals a to the sub n, see it's got a little subscript n there, x plus 2 times x minus 1 times x minus 3i, and that number, a to the sub n, can be any non-zero number. We'll get the simplest polynomial if we let a to the sub n equal 1. Then, if we multiply the factors, we get p of x equals x to the third plus 1 minus 3i, x squared, plus -2 minus 3i, x plus 6i. See? And we can find a polynomial of degree 5 with 0 as a root of multiplicity 1. -1 is a root of multiplicity 3, and 4 as a root of multiplicity 1. So we made a root and multiplicity table before, didn't we? So that was video 11.3a. So we know we've got a root of 0 right here with a multiplicity of 1. We got a -1 root with a multiplicity 3 and a 4 with a multiplicity of 1. Now it says it's of degree 5, and that's 1, 2, 3, 4, 5. We're going to let a to the sub n equal 1. So that's going to give us, using this information, p of x equals x times the cube root of x plus 1. See? Because remember, it's going to be the additive inverse. It's going to be a plus 1 instead of the minus 1. That's going to be a minus 4. Times x minus 4, see? And multiplying, we're going to get x to the 5th minus x to the 4th minus 9x cubed minus 11x squared minus 4x. All right? Now, we had these two theorems in the previous video. If a polynomial p of x of degree greater than or equal to 1 with real coefficients has a complex number, a plus bi is a root, then its conjugate, a minus bi, is also a root. That complex roots occur in conjugate pairs. So that was the first one we had from the last video. And here's that second one. Suppose p of x is a polynomial with rational coefficients and of degree greater than or equal to 1, then if either of the following is a root, so is the other. A plus c times square root of b and a minus c times square root of b, where a, b, and c are rational numbers and b is irrational. Okay? So there's links to that too. So by these two theorems, we know that complex roots occur in conjugate pairs. It tells us here. And we know that certain irrational roots can also occur in pairs. We can use these facts to find the polynomial of lowest degree with rational coefficients that has specific roots. And we can find a polynomial of lowest degree with rational coefficients that has 1 minus square root of 2 and 1 plus 3i as roots. From the theorems, we know that 1 plus the square root of 2 and 1 minus 3i are roots. See? It's the pairs. If that's a minus, then it's a plus. If that's a plus, it's a minus, isn't it? So the polynomial we get by using the principle of zero products is p of x equals, and this is a long one, we've got x minus 1 minus the square root of 2 times x minus 1 plus the square root of 2, x minus 1 plus 3i, and x minus 1 minus 3i. We can use the associative property to regroup these so that we move our parentheses and get x minus 1 plus square root of 2, x minus 1 minus square root of 2, times x minus 1 minus 3i times x minus 1 plus 3i. Now multiplying the sum and difference of two expressions, we get the square of x minus 1 minus the square of 2 times the square of x minus 1 minus the square of 3i. We can simplify this. We get x squared minus 2x plus 1 minus 2 times x squared minus 2x plus 1 plus 9. See? And simplify it more. We get x squared minus 2x minus 1 times x squared minus 2x plus 10. And that gives us, when we multiply, x to the fourth minus 4x to the third plus 13x squared minus 18x minus 10. Our polynomial is of degree 4. See that? See how we did that? All right, now, if any of this stuff with imaginary numbers or I is confusing you, there's going to be links to 7.7a and all the following ones for Chapter 7 that talk about I, imaginary numbers, and their conjugates. There's going to be a link to the previous 7 videos for Chapter 11, and our next video is 11.4. We're going to talk about finding roots and the rational root theorem. All right? So I hope I'll see you there. I hope you're having a great day. And of course, Lola is passed out at my feet, as she always is, if she's not barking at squirrels out the window. All right? And I even have Bitsy here. So have a great day, and I'll see you next video. Bye.